Alright, today we got one of my projects here. This is an Airco welder. It was made shortly before Miller bought Airco. It's a Wasp 2 model welder. It's a 190 amp AC welder generator with a Kohler K301. And I've had this welder for a long time, and I just recently started working on it a few weeks ago. I had the gen end all the way apart, did a little bit of rewiring, cleaned a few things up in there. That's in good shape. It's a pretty well built, nice 4-pole unit. Now I'm working on the, I started working on the motor more yesterday, Christmas Day. And in removing the flywheel, we had some damage right here. Really kind of a bummer on Christmas, you know, but whatever. I just had to pull the flywheel because, you know, I heard some rubbing. I thought it was coming from the stator here, rubbing up against the magnets, and it was just dirt in there, no big deal. The interesting thing is how it happened. Flywheel was mounted, no problem. Nut came off, wasn't too tight. Put the nut on backwards at the end, you know, typical procedure. Pry up against the flywheel a little bit, and give it a couple firm smacks with a hammer, soft hammer. Now, 3 smacks, flywheel loosened up, slid it right off, unscrewed the nut. Went to work cleaning everything, no big deal. Going to put the flywheel back on, wanted to rotate the crankshaft, just to have the keyway vertical so the key couldn't fall out while I was sliding the flywheel on. I was rotating the crankshaft and the end of the crank broke right off my hand. So I guess I must have cracked it, and I just took it off the very last bit. Now, I don't know how that happened. I was hitting the crank pretty squarely with the hammer, so it's not like I would have chipped it off, you know, but hey, it is what it is, I guess. So now, I gotta figure out, well, I want to replace the crank. Not really, because I just put the whole thing back together. I didn't take the rotor off of the crankshaft of the engine, so I'm not sure how much of a bear that would be. I've got a big cast iron fan in there. Or even what the crankshaft would look like. Would be a taper fit, what size it would be. There's plenty of crankshafts on eBay, I looked. You know, they're all for, you know, the John Deere tractors or the Cub Cadet tractors. You know, they all use this Kohler engine, this 12-horse Kohler. But, you know, would they have the taper shaft if it needed one? But I didn't bother to look. So my repair here is I'm going to cut this off cleanly, drill a hole, thread it in the center of the crank. Well, yeah, that's pretty easy to do. You could take the crank off, take it out of the engine, chuck it in a lathe, and just bore it. Or you could probably do it on a mill or a drill if you have the right vise and clamps and everything. But I don't want to go through all that trouble, pulling the engine in half, taking it all apart. Since the engine has pretty good compression, and you know the word is didn't knock before it was stopped used. It was taken out of service, so I kind of want to leave it alone. I don't feel any play anyway in the bearings, so I just want to leave it alone. So I built this. I threw together this little frame. Because I'm going to attach a mag base drill to this plate here, this channel. And if anybody doesn't know what a mag base is, I'll show you in a second. And I'm going to drill the crank while it's in the engine, which should work pretty well. I'll see if I can cut the video and I'll show you the mag base drill. Okay, now I've ground the crank down, found my center mark. Now this is a mag base drill made by Milwaukee. Other companies make them, but we happen to have Milwaukee. Big drill motor. Very slow speed, 350 RPM max. Huge gear reduction, of course. Very similar to a drill press. However, the base here is a giant electromagnet. Concept is, you know, set it on some metal surface, good solid surface, turn the magnet on, and you got a drill press. It's got forward reverse. The speed is infinitely variable through a knob here. Here's a nameplate for all those interested. Magnetic drill press. It's pretty heavy. It's a real well built tool. This is the company's tool, not mine. I wouldn't want to buy it. I wouldn't want the price tag. So what we're going to do with that is mount it on this plate here and go ahead and drill up the crankshaft. I haven't decided yet whether I'm going to use or what size bolt I'm going to use. A 1/2 inch grade 8 bolt probably be more than enough for this. Means that, you know, the original was only a maybe, I don't know, I haven't measured it, maybe 5/8 forged. You can see the inside there, the structure of the metal, really grainy. So grade 8 bolt would be more than enough, I think. So I'm going to set this on this pallet, lower it down. It's hanging by the forklift now. So, because it'd be pretty off balance with the weight of that drill on there. So I'm going to set it down. And I'll come back when I'm ready to drill. Okay, we're now mounted and ready to drill. We got a 7/32 pallet bit, which will be followed by, let's see, 27/64, which is the correct size for tapping for a 1/2 inch bolt, which I decided to go with a 1/2 inch. The original stud was 5/8. I did measure that. However, since we're going to be drilling inside the shaft, I wanted to stay with the smaller bolt to, you know, preserve the integrity of the taper. Don't want to thin the wall out too much. So we're gonna go with a 1/2 inch on that one, and we're all magged up, and start her up. So. A little bit of lubricant. So I'll come back when I'm done. Okay, we're still drilling. That piece of tape right there on the drill marks 1.5 inches, which is the depth that I went to with the pilot bit. I'm going to drill to about 1 1/4 on this one. 1 1/4 brings the hole depth to about the length of the taper on the shaft. That's plenty of meat for a bolt to grab on. See, we're not even at half speed. This drill might be going maybe 150, 200 RPM right now, nice and slow. still got a good wall thickness to the taper. I wouldn't want to go any bigger than a ½ inch for the bolt. Almost done. We're trying to get to 1 1/4. I'd call that about 1 3/8. This should be fine. Not bad. We'll cut back after she's threaded. Alrighty, well, back in the air again. We ended up with about 1 inch of good usable thread. Got some nice, pretty deeply cut threads there. Centered pretty well, as far as I can tell. And that should make the problem all better. I'll mount the flywheel real quick and show you what it looks like. Alright, now here's what we ended up with. Good and solid. You know, it's a shame this happened, but you know, better than having to take it all the way apart. You know, like I said in the beginning, pulling out the crankshaft, assembling the whole thing means new gaskets, time, cluttering up the shop. You know. This took about 2 hours from start to finish. From building that bracket right there to being all done, about 2 hours. So, I think it was worth it. And I'm confident that it's as strong as the original part. Now all that's left to do is reassemble it. With this machine, I still have to clean the carburetor out. I bought a rebuild kit. That's on its way. You can see there's a spider's nest living in the intake. Believe it or not, the engine has good compression. The fuel pump works. I'll describe the machine in better detail once I get it all running and I make a video of it doing its job. You can see I've got these limit switches mounted here. Connected to the throttle. I'll tell everybody what that's all about later. Here are the wires for it. So, yeah, that's it. Worked out pretty well, I think.